Because of the fact that WebAssembly grew out of SMGS, a JavaScript-based project, the idea of a sandbox was obvious. If you think about it, JavaScript in a browser runs in a restricted environment from the day one. You cannot just go read a file from a machine where a browser runs or talk to users' hardware like microphone or camera without explicit permission. The sandbox for WebAssembly is like that, but way more restrictive. By default, in Wasm Sandbox, you can only do some basic math, perform loops, do some if-else branching, and not much more. You cannot even access the DOM, that is, the elements of a web page. This is the deny by default principle. Compare that to Java applets that can make network connections, open, read and save files, access clipboard and more, and all of that can be requested after the applet started executing, which of course makes security audit harder. So unless there is a vulnerability in the browser itself, Wasm bytecode loaded from a random website cannot mess around with confidential data on your machine. The way bad guys are using Wasm these days is called cryptojacking, which means that a random website can still use what's available in the sandbox, your compute power, to try and do some math and with that mine crypto coins. Still, this is nowhere near to some of the worst Java applets or Flash player exploits that gave attackers full control over affected systems.